Hi guys, welcome to day 6 of SQL learning, where we are learning together. Let me quickly check if it's live properly in case there's a problem. It does show it's alive, but let me quickly see here. Yeah, it shows live here. Just trying to see where it should be here. Day 3 by day 6. Hello, hi. There's a delay between here and there. Hmm. Hello. Okay, so I think we are pretty much good since I can see properly how that live is working, and I am the one who joined. At least I have one person watching, but that's fine. It's all about starting somewhere, right? So welcome everyone. Today is day 6 where we're gonna learn a lot of things. But before we move, let me tell me about myself. My name is Nitin and I have 5 years of IT experience. I started this journey because last 2 years I haven't worked in IT, and the break time is over. I want to get back, and I thought like let's revise everything from a structured way because my learning is mostly came from college time, and then everything I learned during uh, my working as an IT professional as senior data engineer. But I felt somewhere that there was no structured learning. I was learning based on the requirement. Okay. So I thought, why don't I start everything from scratch and see how can I structurize everything and to make me motivated because I am one of those kind who try to finish everything in a week. And the problem is like I'm not able to I'm not able to continue the thing, and I always leave things in between. And even if I does that, I don't go much into the depth. I do on surface level of learning, that is still learning just on the surface. That is enough for me to get by. But I thought like as I progress in my career, I need to have more in depth of knowledge. So I thought, why don't I create a method that do two things. First one is increase my accountability, and second one is make sure that I learn things in depth. And what is best method than learning plus explaining to others? The more you teach to others, the retention of knowledge and the depth you learn during that time is far greater than learning by yourself and taking the notes. And that's why I decided to do the stream, because that's why I know that every 12:10 GMT time I have to be live no matter what every single day. So it gives me kind of motivation to be on the live. Okay, so that's the thing. Second, last year when I feel like I need to do something, I did SQL and I curated all the information that I know into this book. So this book I created, you can see author name is Nitin Rawat. All you have to do is go here, and you can, because it's freely available, I will tell you just how you can download this one. And it's free, of course, you don't have to worry about the money. But since I'm not working, if you do patronage is will be really helpful. If you can buy me a coffee is also really great. Okay, so this is the book of sequel that I have created last year, and this is the book you can download for free of cost. And just after a minute, I will tell you how to do that. And trust me, this has all the necessary information that you need as a IT developer, because 5 years I work for Fortune 500. For example, did you use the computer HP like this? So I work for this company. Trust me, guys. So I was handling terabyte of data processing in ETL tool and cloud-based technology like Azure. Then I work on AWS. So I know what are the things that really, really needed as part of SQL developer, or as part of data engineer, or as part of data analyst. And this is something I put in this book. You can simply go here all this one is there for the first part is all about a data engineer and versus data scientist, so there's not much into it. But second part is introduction to SQL, then intermediate SQL. It's very structured. It's for everyone. That's why the name itself is like SQL for everyone. Level up from beginner to data pro. So you can simply search it, and in future I might use it as a reference to learn more into this one. So how to download this one? Simply go to my YouTube channel. Make sure that you subscribe it because that will make me feel motivated that I need to do it. Okay. Simply open this three link in the description. You can read it if you want, if not, because nobody can read nowadays. So this is the website where I have hosted my resources. You can simply go to Code for Coin Gumroad. Once you come here, this is the uh, book SQL for everyone, level up from beginner to data pro. Simply click here. And once you are here, simply it's zero. But if you want to buy me a coffee, you can simply donate some add money here, then go and you can simply buy this thing. Add to the card and then simply buy it. It's same as like how you do it. And in case you feel like this is not worth right now, you can skip it, don't worry. But one thing I can do me for me is like you can write your email ID here and simply subscribe it, because what gonna happen with this one that once I have you register with your email ID, what because I create articles based on what I learn, so I can simply send it directly to your email, or if not, you can simply connect me with my LinkedIn account as well, and where you can get the article that I release every single day for you guys. Even sometime I also release some interesting fact that's may be helpful for you. And definitely few of the articles gonna have very technical things that definitely gonna help you as you progress in your career. Okay. So that was the thing. And in case you really want to buy me a coffee, you can simply come here, buy me a coffee .com/code for coin, and this is the page. So nothing much on this one. So I think I can close it. Now let's get back to day number 6, where we're gonna learn about creating table in Postgres. Okay. So anyone join now? That's okay. No bother. Click here. You have to go to GitHub repository because this is our source of truth where we are maintaining all the resources for us. So this is the first repository in which you need to go to this directory, this repository SQL structure query language, where you need to come to fourth directory, that is your SQL 0 to hero. And we're gonna learn about what we need to learn. So this is the roadmap 002. We are done with what is SQL. We are very clear on this one. What is database? We are very clear on this one. What is relational database management system? That is RDBMS. And we are also clear on this one. Installation is also done. And yesterday we work on database, but don't worry, we will try to retouch it because every day we try to recap the previous 2 days. So we're gonna do that. So today is our creating tables and dropping and altering tables that we need to learn. Okay. Before we move, we need to ensure that we do a recap of previous 2 days. So let's do for yesterday. I think I haven't created that thing because I was working for my part-time job, so I was not available at that time. So don't worry about this one. I will just recap for you. Day number 5 and day number 6. For day number 4 is totally about why we choose Postgres as relational database management system. I think someone joined. Hi guys. If you are there, just write hi. I just give you a brief that I'm learning and teaching at the same time the SQL. So today is day 6. We're gonna create a table, and before we move, we are just keeping recap of day 4 and day 5. So let's go to the day 4. Why we choose Postgres? That's really interesting. So before we move to Postgres, let me give a brief about what is SQL, what is your other things. Okay. So if you talk about SQL, SQL is a structured query language. Why we need it? Because in our day-to-day life, most of the finances, most of the your banking system, most of the data that we were using, we found that it is in the form of table. Okay, and some of the inventor thought, since most of the data that we are using and very useful is in the form of tabular, why don't we create something as form of English that at the back end goes here, process this data and give us back. So you don't need to do programming, because all the programming stuff of connecting, taking, processing, and giving the result is totally up to this thing. All you need to know the language, or this English simplified thing. If you know this one, programming or the engine will take care of your programming. And that's where SQL, SQUEL, SQL came into picture, not SQL. SQL stands for as for structure, E for query, English. This is a structure, this is English. This is QU is query, and alpha language. But due to some trademark issues, they need to settle down for the second best name, that is SQL. As for structure, Q for query, and alpha language. Again, same. Structure means when your data is being stored in a particular format, that is our tabular format. That's why it is called structure. Query, because we don't do programming here, we do querying. We ask our engine here to process this data and give us the information that we need. For example, I need only top 5. So in Python, you need to write a code to connect to this table, then load in your memory, and then get that information. Right here, you don't have to do those things because engine will take care of that one. Only you have to do is to ask for the information that I need top 5 or random 5. What random 5? Your samples from this one. That's it. So that's why this SQL or SQL is called declarative language, because you declare what you want, not imperative where you have to define everything. So it's talk about what you want rather than how you want. How is for other programming language. And L again is a language because it have words, that is keywords, and then it have a grammar, that is your syntax. If you know these two things, you will be able to form a query, and when you shoot this query on your engine will retrieve the information for you from that table and give it back to you. So that's the concept of SQL, why it came in and why it was needed at the first place. Now database, what is database? Database is nothing but collection of related tables or SQL tables that we're gonna use for those tables that we're gonna use SQL programming language to process the data and retrieve the data. That is database. Got it? So it's not a big deal. Database is just a concept of keeping all the tables that have certain kind of a relationship with one another into a same space. So access become easier, processing become easier. So this concept is called database. Okay. So now the concept of database, people, and to communicate these things together and process the data using SQL is being implemented on a software that we call relational database management system. You got it? So relational database management system is nothing but it helps you to create the table, store them in a format of database or in a database, and then help you or enable you to execute SQL queries and fetch the result for you. So everything is implemented on a computer or machine using a software called relational database management system. This particular software that enable you to store the tabular form of data in a database, then help you or enable you to query those tables using a SQL programming language is called relational database management system. So relational database management system management database management system. Since it's a software, so multiple companies has created multiple software like MS SQL, SQLite, I think LIT. Then your Microsoft SQL Server, and there are many more. And then is PostgreSQL, PostgreSQL that we're gonna leverage. Okay, first of all, the reason we are choosing it is free and open source. That means today, if you want to design and create your own product that works on relation database management system, you can directly use it. Even you can change its architecture and create a all new product. So you can play as it is. So University of California created this one. Then after many decades, the 18th version is released. So using this one, you can create anything. You can change it anything, and you can simply rebrand it and sell it. Okay, that's the powerful licensing they have. You don't have to worry about licensing and everything. That's the best part of this one. And that's where somewhere a lot of enterprise level, like even mid cap or small cap, prefer a PostgreSQL nowadays. Third is that I individually like is integration. Nowadays, it can integrate with all the major cloud-based services like AWS, Azure. So that's the good thing. But fourth that I really like about is customization. That is not present as much as Postgres offer. For example, you can create your own custom data type. You can create your custom functions. So you can create so many customization that it feel like this is your native home. You don't have to worry about anything. You can simply do anything. The fifth one that I really, really like about is extensibility. Extensibility. You feel like there are certain data that cannot be processed through your uh, SQL programming language, and you need something more than that. But don't worry, you can simply write your code in four of this procedural language, that is functional language. It can be Python, PGSQL, then your TCL, for any of this one. I think Python nowadays famous. You write this code and a data handler that is pre-built in PostgreSQL. It will take this code and start executing on your database. That's the best part. I love it. I never tried it. I need to try it. I really, really want to try it. And for that's it for day 02. Why we choose Postgres. Day 04. Day 05 is all about getting started with your PostgreSQL, and then creating database. And then today for day 06, we're gonna create SQL tables. That's the something we're gonna do it. Okay. Any question? No, nobody joined. That's fine. It's our learning anyways. Okay, so day five. Before we move, we need to understand one more thing that we learn on day five or day five. That is architecture. So PostgreSQL as a software work on client server mode. That means you don't need to host it on your premise. You can host this particular software in some other computer and provide it as a service. Okay. What it does, if it is your machine means computer, you can install this in any machine. Okay. So remember, server is the machine where your software is being hosted. Okay. You can host it in your own local machine. Then you can say your server is your local machine. Server means the machine or computer where your software is installed. Okay. But if you want to act as a service provider, what you can do, you can install this in some other computer server. Okay, here you install your PostgreSQL. That means now the server has IP. The IP for this one, when you do it, this local IP, 8080, I guess. I need to check that one. I don't remember. Okay. So either of the cases, what happened? The client sent the request what he want to do. Okay. When you need a person or interface that interact with this request and check authenticity of this request, whether the person who is trying to connect with uh my RDMS, that is your PostgreSQL or the PMS, Relational Database Management System or database, is it authorized to do that or not? If it does, it will send request to this guy if authentication passes. Okay, and then he check for everything, like if he's the right person, if he have the right authority to do that or not, and then give the result based on that one. If it's error, he will send the error to this one and then this one. If not, then whatever is the thing. Okay. So this is the concept of client server. So there is an interface that talk or take your messages and then give it to this one and then do it. So this is called master server or master node. And this is other secondary node where your actual this one is hosted. Hmm? So if you want to understand this in a basic thing, so suppose you are a person A, then there is a person B and there is a person C. Okay. This is a hotel. This is the same example I gave you yesterday, and this is your guard. Okay. You come here and tell that I have a reservation for a table, and this is cook here, and this is only one table here. One table means one computer. Okay. It goes here, ask this server. Okay, using the address, he comes to this hotel using this address and ask this guard that I have a reservation. My name is this one. Can I go in and dine? He will check his directory. Okay, this person seems to be legit. This is the software I have hosted. Means this is the table he is reserved it. Okay, you can go it here. Okay. Then he will tell the cook that I want to eat this one. He will eat it. So this is the request message that goes here request, and then he does that. Second person came in. He told this guy that I want to go in and have a dining. He said like the parameter you provided, like it's not belong to this hotel, it is belong to this hotel B. That means his request is cancelled. Third person came in. He was like, I have a reservation for hotel A, and he say yes, everything is right. He does want to go there and he want to dine here. But he found that the only table that available for dining is being occupied, so is congested. He will reply that right now it's not available, wait for it. So this is called network congestion, where this resource is completely occupied and you can't use it. Once he's free, okay, he's like, okay, I ate it, he will go. And then he will take his request and send it here, and this guy will start eating. Okay. So this person who regulate this messaging everything is called master server. And this is the second computer secondary node where you host your actual this one, and based on the load it try to distribute to different computers. So client and server is basically to make sure that you are available, you make your service available online. So that was important. Now for the other thing that we learned was database creation. Okay, to create a database, we know what is database, right? Firstly, you need to connect to a server, and to connect a server you need something that enables you to connect this one, your client side. So it can be some user interface level of software, or it can be Python code you have created by yourself when you put your username and password then try to connect with the server. that we will show you again. Okay. Then using this one, once server is connected, you will send a request to server that I want to connect to my database, this one, database, and retrieve the data from table A. He will send the request, he will check, authenticate everything. Okay, this person seems to be legit. It have all the permission to access this one and retrieve the data. He will go back, send the data to this guy. Okay. So let's quickly go to your. So PG admin is that software that helps the client like me to connect with the computer where my database or relational database management system is hosted or installed. Okay. Right now, that database management system is installed in my computer, in my local machine. That means the IP should be my local host or my local machine. So if you look here, the server, here the server, okay? This is the server, and we have created two database. One is Postgres, second one is a student. Okay. So if you go here, welcome here. So this is that page I was talking about that help you to connect to that server. So now server is server means the computer where my relational database management system is installed, right? So I click here, I see this is the server, I click it here. So see the server name is this one and host name or address is localhost. So it will automatically send the request to my own computer on this port, and since this SQL server, the Postgres server is hosting into this one, it will automatically receive the message and start processing my request one by one. Okay. So I already connected through, I think it's not there. We will connect it again for your convenience. Now, this one is asking me, okay, you already connected to this machine where my relational database management system is hosted, but which database you want to use? The same thing I told you. Relational database management system is your service or a software that provide the creation of database and its management and then help you or enable you to fire SQL queries on this one, right? But what is database? Database is nothing but the collection of related tables, right? That means you can create multiple databases. Like say, this is the database for student, where all the information about the student, like their IDs, then their personal information, then their professional information. You can create multiple tables on it and form some relationship between them using primary key, secondary key. And this is something we will learn along the time. You just need to understand. Then you can create one more database where you can have the information about the university into multiple tables that have some relationship with one another. And again, this relationship is being formed using primary key and secondary key. We will learn more about this one and why it is important. But the question you should be asking, no one joins. The question I should even asking myself why we created this multiple databases, right? Answer is very simple. The logic of creating this one is to increase modularity. Suppose you created one relation database management system, there you created one database in which you are putting every table. Now the problem is a student have access to student information, then he have access to the professor information, then he have access to the professional salary as well. When they start gossiping about that my professor A is getting this much, he is not getting that much. That means it's a breach of privacy of someone, right? So you need to create a segregation based on certain theme. Here theme was student, so you created one database for student. The theme was here is professor. So you created a database for professors. Okay. So now what gonna happen? You're gonna play the role of admin and give the access to an individual based on which theme, which database it belongs. Suppose a student came and you as admin thought like, okay, he's a student. What most he can access here, he should be student, not professor. So yes, he get the access to this one. Second one is a professor. He get the access to professor, but he got the access to the student as well because he need to create exam sheet, every many thing. So he have the authority. He needs this data, so he have access to the board. You see now how convenient it become to showcase to an individual based on your logic, based on the requirement. This way you hide the other data. It increases security. It increases the power or the authority to the data based on the user requirement. So that was the thing that you need to understand, why we need to create multiple database within relational database management system. That's essential. Okay. Now the most important thing that we learn here is how to create a database. So to create a database using PostgreSQL programming language is, that is also called PLSQL, PGSQL, PGSQL. So Postgres, the SQL language that it provide, it called PG, that PostgreSQL. We write it in a shorthand like this. It's nothing but PostgreSQL. Using this one, we will, so now using PG admin, that is our graphical interface or the software that we use to interact with the machine, enable us to connect to a server or a computer where my relational database management system is hosted, that is our PostgreSQL, and it helped me to connect to that database. Okay, so right now if I access this software, okay, relational database management system, that is Postgre. Okay, now this is empty sheet. If you look here in the big picture, it's empty. I am here. Okay, is, and right now I'm representing nothing but PG admin. Here's the server in this computer, and this is the software relational database management system. Okay, I need to create a database. This is empty. I will connect to it. Okay, connection is done. Now I will send a request to create a table. He received this through this one and he connected you to this table. Now using this server, I am able to form a direct pipeline to my relational database software management software. Okay, so now I will send a request to create a database. The request is going. It comes here. My software RDMS read it, and okay, he realized that the person who's sending request is is actual person, and he's registered into our authentication register. That means he have the all the permission to create a database. So I will give him the blueprint of database what I want to create using SQL query, and then he will create a database here for me. Now see, this is the first database I have created this in this empty relational database management system. And right now this database is completely empty. That means it doesn't hold any kind of information, right? Nothing. Correct? That means we can create tables now. But before that, we need to understand this one. What was the blueprint we have given in the form of SQL or PGSQL query that enabled relational database management system to create a database? The query was simple. It is create database and then database. So DB, if you see somewhere DB, that means database itself. DB underscore name. You can simply give any name for us and then semicolon to stop. Remember, always put the semicolon when your query is completed, because if not, it might create a havoc that I will discuss some other day because there is an interesting story to that. Okay. So now we have fired one database creation query yesterday in day 5. Let me write it down for you. So at the back end, the query that executed was create database, and database name was student. And if you want to put more features to this one, then you can use the keyword with and then feature. This is something we are not concerned at the moment, so we will not use it and we will simply write this. This will help me to create this database. Okay, student. So let's quickly go to admin. Now let's get back to the practice. This is the server we want to connect, and that is hosted on the local machine in this port. And then we want to connect student, but I think we should create it again. So here in the server PostgreSQL, this two is created for a student one. Let's delete this one. Let's see if we can delete. See, dropped here. Let's drop it. Are you sure you want to drop the database student? Let's drop. And the SQL query for the drop will be drop database and the database name student. But I need to see, can I do it using SQL query rather than directly using this one? Cancel it. Dashboard, properties, SQL. Okay, so see, this is the SQL. This was the data student. Let's see if I can drop this one. Okay, I cannot do it. Let's see if I can go to the SQL Server port database and user. So welcome to PLSQL workspace. The PSQL tool allow user to connect to Postgres or EDP advanced server. Using the PS connection, this workspace you can seamlessly open and manage multiple PSQL tab, which is easier to organize your work. You can connect to existing server or create an ad hoc connection to any database server as needed. Okay, it's the same thing that we were doing here. So let's connect here. The query tool is robust and versatile in this one. Okay, factory in this workspace, you can seamlessly open, manage multiple query tab, make it seamlessly organize your work. Okay, but since it's directly connecting to database, okay, let's connect. Let's see if we can drop this one after connecting to database. So this is the database student we are correcting. This is the Postgre, this one. Let's connect to this one and try to delete the student one. Okay, this is the Postgres. This is the user automatically created. Password you should remember. Make it very simple. I think role you don't have to define it. Let's check. Okay, so now in the server server was our this one PostgreSQL 18 that is hosted in our local computer. Let's see, can we drop our database that we created on this server? Since we are connected with, problem is like we connected with the database, this one, right? Postgres. So thing is, we have two database so far created. First one default that I got when I was is when I installed this software. So default one Postgre that I connected right now. Not sure whether I have the. The second one is RMate that we created yesterday. So another database that we self created. That is your student. Right now with the connection, we are connected to database Postgre. Now we need to see if we can delete student DB database. So drop database student. Remember, you need to be ensure that the name you're putting is correct, even the keywords is right. Let's see if we can do it. Now it's executing. Let's see it does or not. Error. Database today is being accessed by other user. There is one session using this database. Th- That means somewhere somebody is using this one, and that's why we are unable to delete it. Where is it being used? Is it this? Closed. Backend dependency. Uh, if I was thinking like if I log in directly, then because you are able to do it when you use it command line, but why it is open, right? Let's see if execute. Error database student is being used by other users. There is one other session using the database. That was the thing because right now the connection or the only connection I formed is to the database Postgre, not the student. So it should be idle at the moment and I should be able to drop since I am able to access the server, right? But why I can't do it? Welcome. Why I can't do it? Why can't I do it? Why can't I do it? And where is open? Can I close forcefully all the connection it have properties query tool? See, it's connected directly to this one. We can do this as well. Can you drop it here? Drop database student F5. I need to do that. Currently open database is open. Obviously, it can't do it. Don't save it. Let's close this one. Don't save. I don't want to save it. So right now we have closed the connection that we use in query tool. Let's directly connect to database. Disconnect from all the database. Okay. Are you sure you want to disconnect? Right now I'm trying to disconnect. Okay, now see this has completely become uncolored. That means I have completely disconnected with this database. Now refresh it. Let's see if I can connect this one. Create. So now I'm going to query tool. What is the one for this one? Alt Shift query. Okay, Alt Shift query. Now I connected to the database in the relation database management system that is PostgreSQL database. Okay. Can I delete the student which is offline at the moment? Let's see. Drop database student and run it. See, it's dropped. So one thing we understood, if you connect and if your database is live in that connection, that means you cannot drop it. Let's refresh it. See, it's gone. Okay. That means this is working. Okay. Drop database is working. Can I comment this out? Yeah. So remember, this is the experience. So for comment out, use to hyphen or to dash. Okay. Now let's create our database. And we learned that in SQL to create the database, we need to use two keywords. First one is create, and second one is what we need to create is database. And now if you simply run this one, it will throw error because create database. But what database? I need to create a database called student. Okay. If you see the convention, I'm using the capital letters for this one, your keywords, and the small letters for the naming convention, or the one that is being used by me. Okay, that's not universal. This is universal. We do this one that the query becomes simplified. It looks simplified, beautify. Okay, that's the reason. So create database student. Now, if I run this query, what do you think gonna happen? Let's run it. Do you want to run this query? Answer is don't ask me again. Yes, I want. Now the query has written me in 1 second and 826 millisecond. But you see on the left side, nothing, no database created I can see with the student name, right? Why? Because this is static. So once if you send a request, then only it will retrieve the latest information and it will stay static till the time you raise a request again. So I need to raise a request to refresh it and see whatever the changes I made now should be visible here. Refresh it. I can see it, student. Now, interestingly, see, this student is completely uncolored. That means it's not active, or I haven't created a pipeline and connect my this system, this client interface to that what? To that database. Because right now I'm connected to the server. That's why I'm able to run on Postgres, right? I am connected with, let me show you this one quickly. So this is the me. I created a pipe that my server has allowed to go, and then in my relational relational database management system allowed me to come in because of my user and password is matching in his user password logs or sheet. Then it allowed me to connect to database called PostgreSQL. I created another one because since I can access this one, that means I have access to this one. I can run any query now. Okay. I have access to this one. That means if I run a query for accessing any table on this one, I can do it. But can I access this table? Answer is no. You can fire a query on this one, but you cannot access this one right now because you are not connected with this. That we need to create a connection. And how to make the RDMMS understand that I want the access to this database. Okay. Because you remember what I did when I created this one, right click on this one and then query. To query to what it does, using SQL Server, I am already connected till here, right? So let me restart this one just a bit. Okay. So initially you have only one database here. What you did, you send a request to server that I want to connect to this Postgres. He will check the authenticity of IP address and then the software. Both are available. So he was like, okay, you are at the right place for the right service. I will forward you. He will forward to relational database management system. Now he is connected to this one. But to access this one, you remember did one is to right click and then I select the query. What it does the query, it send a request to relational database management system here that he want to connect to this database. And he saw all the credential that username, password, everything is matching. He will allow you to go here. Now we are good. We are into database. Now we can access this database and do anything. During this time, when I was here, I sent another request that was to create another database student, right? He will send this equal to relation database management system. He will check your authenticity, then check do you have the power to create a database into this relation database management system or not. Yes, you have. He will create a database for you, student. He created. We are not connected to that one like this, right? Then I need to send another query that goes to my relational database system and tell them that I need to establish a connection with this database as well. And then he will create this connection. Now you have connection to both of them, and then you can utilize both the resources, that is both the table inside this database, right? We are clear? So to create or to send this request, we have a SQL format. called use database. Database. I think name should come student. I'm not clear because I usually use directly that right click on this one. That's why this session is all about to see if this work or not, then we will simply check. So now table is created, your database is created. We saw this one, so we will just comment this out. And that's why I told you semicolon is really important at times. This comment out. If not, what's gonna happen if you execute again? It will drop it and then it will recreate the database again and again. And it's a overload because you are making a system do the same repetitive work that doesn't make sense. Okay, so it will just increase the network congestion, which you keep on sending a request that doesn't make any sense. Okay, so now I'm not sure will it work or not. I need to check. Use database student. See, there is a two tab. One is F5 that execute the query where your cursor is. It will execute the query on this one. On the line 4 till he received this semicolon. Okay, so if I do this one, so semicolon is here, so he will search for all the queries till here. Does it work like this? Or yeah, it will execute the line number 6. So if it's a one line command, simply use this one. And if it's a multi-line command, you can simply use this one. Now it should work. Now syntax error. So I was right. This is wrong. I think I don't need database. Let's check it out, dude. Let's check it out. How to access database SQL command for PGSQL. Because we are looking for the SQL that is offered by Postgres, right? Not interested. Running the process terminal monitor this one. Accessing a database, let's see. Once you have created a database, you can access running the Postgres interactive terminal program called PGSQL, which is interactive editor SQL command. Use this one, PSQL MyDB. Is it MyDB or something, dude? I don't know. Select version. How to access it, dude? Or is it possible that I created this on this one? That's why I can't connect it. For this one, I need to create a separate connection together. That's interesting, right? I want to know like what use database and database name command use for. Select the default database for the current session subsequently. Database name command in PostgreSQL. Like a Stack Overflow. This is the best I ever found initially. So I am a beginner to Postgres. I want to connect to another database from the query editor of Postgres, like use command. This is the one use database name. Yeah. So you using this command use and then database name, you will be able to form that connection that I was talking about. But when you get a connection to Postgre SQL, it is always up to a particular database. To access different database, you must get a new connection. I was right on this one. So that's what I was talking about. All the different software that enable you connect to the particular my RDBMS, they have their own set of rules. So right now, the core concept was when you use PLS SQL command line, like command line. Okay, this is your relational database management system, you use create database, say DB1, it will create it. When you write another create database DB2, DB2 is created. But if you want to access a table inside DB1, DB2, here T1 and this is T2, okay? If you want to access this one, you need to get access to this table, and then the command is use database name, that is DB1. Now you have already connected to this one with the server connections, right? This one. Now to connect this one, you need to use this one DB1. Now you have all the access to all this table, but you don't have access to this one. Then you need to use it again, use DB2. Now you have a connection to this database as well. This and initially this one, and now using use one, then use this one. You have access to both the database. So to connect with the database, you can use database, but in PostgreSQL, every connection is to a specific database. You cannot connect to two different database in the same connection. And that was initially I was skeptical about when we were using this one. Remember this one? We were connecting to a particular database. So it answered my question that to connect to a particular database, you need to create but to a new connection. But if you drop all the connection to that database, then whatever the connection you form to different database, because you are connected to RDMS, ultimately you can delete and drop that database. Okay. So since this is the case, let's form a connection to this one. We can't do anything. Now connection is formed. Now I will open this query tool. The moment I touched it, automatically get connected, and I think I can disconnect this one. Export. Do we have anything like disconnect from the database? See, are you sure you want to disconnect from the database student? Disconnect. Now it's disconnected. Now there's nothing that is connected to this student, is isolated. Now I can drop it and then I can recreate it as well. So why don't we do it again? It's fun. Let's drop it. Run all the queries. Since I run all the queries, this is commented out the creates, it won't create. So I will run all the code here. So now this is still there because it's the static one. Error student is being accessed by other users. Okay, so I think I should. No, how is this possible? Refresh. Drop database student. Data is being accessed by other user. Who is accessing, dude? We just disconnected, right? Uh, Disconnected from database. You sure disconnected? Yes, I did disconnected. Cancel. There is other session using this database. So I think we need to stop the remove disconnect from the server. Disconnect from, dude. We did it just a couple of seconds. Uh, Create, refresh, backup, script, maintain, PL tool, SQL query. Drop database. Okay. Hmm. That's really not good thing. See, I already closed all the connection to the student. It should have dropped it automatically. But what I have to do is to disconnect to all the Postgres first. then connect again, and then run the query. This is not the right way, dude. This is not the right way because ultimately, since I isolated this database using this connection, I should ideally able to drop it. But if I am not able to disconnect to a particular database, even after that, that means there's a problem with here, dude. There's a problem. Anyways, the shortcut around is you need to disconnect to your all the database, then connect to one database, and then run this query that is your top database or this one. Now we are commenting out this one and simply create database student because we are good people. Now create it. Since it won't come here because it's a static interface, you have to refresh it again and again to get the latest information. So we will just refresh it. We got the student. Now we will activate it. Once I click it, it automatically connect to this one. See, connected. Now I need to create a tab where I can write the SQL and it automatically fires or execute on this one. Now I am connected to student database in this server. This is properly written route. This is the database I am connected to in this server. Very simple. Right now, this database is completely empty, and you see it. Everything here is empty, but you see here schemas here. There's a public scheme, right? Again, this is very interesting. As you know, that database is a collection of tables, right? But it is more than just that. Similarly, if you remember what I told you in relational database management system is nothing but a collection of database and it enables you to fire the SQL queries, right? And database is nothing but a collection of related tables. But you remember what we did in the previous example that we created DB1 and DB2 for student and then prof to segregate the data. But sometimes you created so many databases that it become really hard to understand. Or sometimes within the database, you see fragmentation, you see groups. And then where you realize that particular user need a particular group of tables that make sense when grouped together compared with the other tables. Okay. So in a database, you can create partitions or you can create multiple sub databases using schemas. And this is something I need to touch more into it. What is schema in a database? This is something. Database schema is considered the blueprint of a database, which describe how the data may relate to the other tables or other data models. However, the schema does not actually contain data, a sample of data from database in a single moment of the time. I need to check this out. Typically, a schema represent a single use case project or team sandbox. That was I was talking about the segregation. Regardless of a category type on this one, I need to because it confused people. A database schema is considered the blueprint of a database which describe how the data may relate to other tables or other data models. However, the schema does not actually contain the data. Okay, is it a blueprint of database? Hmm, interesting. Type of database is conceptual, logical, and physical. While term schema is broadly used, it is commonly referring to three different schema type a conceptual database schema, logical database schema, and physical database schema. Conceptual schema offer a bigger picture views of what the system will contain and how it will be organized and which business rule are involved. Conceptually model are usually created as part of the process of gathering initial project requirement. Logical database schema are less abstract compared to conceptual schema. They clearly define a schema object which information such as table name, field, all this will be integrated constraint any rules that governs the database. However, they do not typically include any technical requirement. Physical database schema provide the technical information that the logical database schema type lacked in addition to contextual information such as table name, field name, entity type, etc. That is also include the syntax that will be used to create this data structure. Hmm, got it. And public schema and table. Oh, ah, okay. Mm-hmm. Then it become a use case, a rough diagram, conceptual, then use case, and then implementation. Oh, okay. Okay. It makes sense to me now. It makes sense to me now. It does make sense. Okay. Based on my understanding of a schema, this is correct, but it is mostly the end result of a schema, not the schema itself. It's end result. For example, you eat apple to become healthy. Healthy is the end result, not the apple, right? Similarly, schema, this distribution is the result, not actually what schema is this segregation or grouping is the result of a schema, not the schema. What schema is, I understood after so long. Okay, uh but the spelling of schema, dude. Okay. Schema, schema, schema. Okay, schedule schema. Okay, okay. Schema is a blueprint of database. Okay, to make you understand simply, today if I ask you to create a house, how you gonna do? You won't simply go and started digging and then started putting the cement and then started getting the stone, the bricks, putting them together. No, you won't do that way. First, you need to go and contact an architect who on a sheet of paper will draw a measurement of the houses, how it gonna look like, the door, the staircase, the window, and etc. And using this one from the top level, you're gonna start creating a foundation on that piece of land, right? You will dig, then you will cement this, then create all this thing. And once that is done from 3D perspective front, you will start constructing the house, right? This is the three phase of development. First one is called concept. What concept of house you're gonna build? So it's conceptual layer. Second one is more detailed when you start founding on all this thing like what gonna happen, what the brick, what it's like more detailed, and that's why this one is called logical. In conceptual, you are like, okay, I'm going. Okay, I think I can make it much better for you understand. Let me do it again. So if I ask you, you have to create a house. How you gonna do? Firstly, we will have a discussion and list down what things we needed. Okay, it's very rough. What we need? We need bricks. So if I have to create a house, bricks is separate. I need what you talk about. I need three bedroom. I need one bathroom or restroom, one kitchen, one veranda, a roof, one roof, staircase. So these are my requirements, right? This is the discussion and the requirement gathering. Is requirement gathering. Second, I will go to an architect and ask him to draw picture of my house. So he gonna take a piece of paper, he will read your requirement and then start creating. Okay, this is the length. I'm going to create an house of this length and breadth. This is where it's going to be a main door. This is your living room. This is your dining room. This is your kitchen. This is gonna be window. So he will create a view, a logical view or a 2D view for you, and then I will start putting the foundation on the first time, and then second I will start building the house. Okay, that's how you do it. First one is information gathering. Second one is the logical creation, how it gonna look like, and then implementing this on the real life. This layer is called conceptual layer, or you can say requirement gathering layer, where you jot down all the requirement overview. Then you get in contact with architect that create a logical view, how it is gonna look like, the blueprint. So this is the blueprint, the logical view, where you will define the dimension trees and but on the third, when you will start executing or constructing, you will know which bricks you want to take, which wooden type of window you're gonna create, what kind of a door you're gonna create. It's more in detail, and this is the real construction, the real execution, and this is called physical implementation. Physical implementation, first is conceptual, second is your logical, third one is physical. And these are the three phases of schemas. So all these three phases is called schema. Schema at logical level, schema on conceptual level, schema on logical level, and schema based physically implemented. So if I have to crux down, it's complete, but entire this process, if I have to say, is nothing but it is giving you a roadmap to create a database. So schema is a roadmap for database creation, right? So how, if I have to create a database, you need to connect to your client and understand what is requirement. He have a student data, he need to store this one, then he have a prof people that he need to store it. You get the overview, and based on this one you will create, okay, this is relation database system, I will create one database. I will create database. Okay, this relation database is rdbms, this is database. I will create a table for student, then I will create a database for professor, and I will link it like this. This will be the table name. This is the column it will have. This is the data type. All this one. This is the construction. Okay, something like this one is for a student or something. Then on implementation layer, you will be more specific. What gonna be database name? What will be the proper table name, column name? How it's gonna define? What's the constraint? So it's more in detail. So if you see from the start till the end, this entire process of connecting with the client till the point of database creation with all the features, this the entire journey itself is a schema. So a schema is nothing but a roadmap of database creation or blueprint, because ultimately this is what happening, right? We are creating complete database, how, using this process. So a schema is nothing but a process of creating database, a roadmap for database. So in simple terms, you can write it down for your understanding. Is a process of creating database. Second, you can say is a roadmap to create a database. Or third and finally, ultimately, what is happening? It is giving you the way of creating a database. So it's a blueprint of a database. So you can say all three is right. Process of creating database itself is called schema. The roadmap to create a database is schema, or blueprint to a database is a schema. Any of this fine. But you understand, right? From gathering information from client to create its logical view, this is called use case. And I need to learn this one as well. And then ultimately this one. And this is very essential because this will help you to be more proficient in system design. What's the time, buddy? Oh, dude, we already exceeded too much. But it's fine. I can't take it much time. So today we learned schema as well, dude. That's pretty good. I was always confused now. At least I can tell what is a schema. And you saw one more thing, right? So inside a database, I can create multiple schemas based on my requirement. Okay. So similarly, how I was creating multiple database inside a relation database, I can create multiple schemas within a database, right? It's possible. And that's why you see it here. The schema, the default was like for server, the default database was Postgres. For Postgres or any database, the default schema is public. I can create more schemas based on my requirement for that database. For student, I don't feel like I need to create separate schemas. One public schema itself is okay. But if I have to create multiple schemas, I need to create multiple something for a student. It can be one personal schema, one can be a professional, one personal, one professional. I can create two schemas, right? So, for example, I have a database, as you know, student, and now I go to students because he's my client, right? And I told him what his requirement. He said, I need to be able to access my personal and professional information, but I want to keep my personal a bit private than professional. So I thought instead of creating two tables inside public, why don't I create two schemas? One will be student personal, one will be student professional. And this one become private to particular user, and this will become this one publicly available. Okay, and then based on this one I will create use case, and then in the use case then I will implement simply. Is logical, is conceptual, is logical, and that's how it is you can create. But I need to understand how to create a scheme. I think it should be create a schema and a schema name, let's say it, because it's English, dude. Even if you don't know and you don't want to search, you can simply hit and try. Sometime it does work properly. Let's see if I can create a schema for public and private. So create schema, because I'm already in a database this one, so automatically schema will be created here. Student underscore personal. Query executed. See, I told you it's very simple. And now we will just refresh this thing. Refresh. Here I got this one. Now instead of personal, I will create another schema called professional. Because student told me that they need two different segregation based on the privilege they have as public and private. So that's why I created two schemas. Let's run it. Is executed. Let's refresh it. So I created two schemas. Now inside the schema, I can create the tables based on my requirements implementation. Yeah. So suppose on the personal one, I want to create a table And how to create a table? Again, create table name, but I want to see the structure. So simply let's go to right here, this one, home, about, documentation, tutorials, PG exercise, excellent documentation, and syntax, data definition, manipulation, query, SQL syntax. No, we don't need it. I need to create no, dude. Table creation. What is Postgre brief history getting started? Accessing database. This is not something I'm looking for. SQL syntax, data definition, basic table, basic default value. Okay, so this is the one, table creation. So a table in relational database is much like table on paper. It consists of row and column. The number and order of the column is fixed. Okay, this is interesting. 12:31. Now I'm thinking, dude, should I continue doing unique constraint? Before I move here, I need to see something. Getting started and okay, this three is done, right? Installation is done. Architecture we read. Creating database through PGSQL is done. Accessing database using pgadmin is done. So this four is done. So preface we already did it. Tutorial done it. Now we need to start with this one. Say if it do this much, it will take years to complete. Confidence control. Performance tip, parallel query, concurrency, full text search, indexing we did have, type of conversion, function and operator. We don't need to bother this one at the moment. Data type. Okay, so this is the one we are looking for. Constraint, schema inheritance. That's something we have. This one today we are into default values. Okay, so creating default values, table basic. And do we have anything else? Identify columns, generate columns, constraint. But what is this one? Create data type and basic. SQL language. SQL syntax. Concept lexicon. Do we have that thing as well? Order by alternate. Inner join, full join, sub join. Okay. I am into lexical, right? Is it lexical? Identify. And there is constant operator, special comments. SQL input consists of sequence of command. A command is composed of sequence of token terminate by semicolon and strings. I'm thinking, should I go in this way? But if I did string consider with escape, bit constraint. Okay, lexical everything is here. And then the next one is value expression. Color phrasing, substance, field selection. But operator function, aggregate expression, window function. I think I should not delve this deep. Maybe some other day if I created a live session for like for 8 hours or 9 or 10 or 12 hours where I have to complete all this one, then I will think of going so down this one. But right now, this is not required for me, and we are already constrained with the time. Delving much into this doesn't make sense. You need to have the basic understanding what the system is, architecture, and in and out, and then simply start doing these things because that's more essential than learning what is semicolon, how it is used, and everything. Let's go to table basic. I need to understand there are few things called identify and generate column. Identify column 5.2 default values. And table basic. Okay, so this is the one we were supposed to do it today, and we will do it anyhow. So what is table? So table a table is a relational database. A table in a relational database is much like a table on a paper. It consists of row and column. The number and the order. Remember, the number and order is fixed, and each column has a name. So here, let's go. In a in a database, table is again same as your paper table. We have rows and then we have a columns. The thing is the order and the name of column is fixed. You cannot simply change their position, from second to third, third to fourth. That's what it said, right? The number and the order of the column is fixed, and each column has a name, and that's interesting. Each column will have a name. The number of rows is variable, okay, because number of entities I was talking about. So it can have as much as entities you want, same as having zero or having as much as you want the storage capacity. It reflects how much data is stored at a given moment. SQL does not make any guarantees about the order of the row in a table. SQL does not guarantee. It gives a guarantee on your column position on the order, but it does not give the guarantee on the order of rows. Okay, that's interesting. When a table is read, the row will appear in an unspecified order unless sorting is done explicitly requested. Oh, this is also interesting. This is a cover in chapter 7. Furthermore, SQL does not assign unique identifier to the rows. So it is possible to have a several completely identical row in a table. That is called duplication. This is the consequences of mathematical model that underlines SQL or SQL but is usually not desirable. Later in the chapter, we will see how to deal with these issue of duplication. Each column has a data type. The data type constraint. Each column has a data type. Okay. So now we understood so far that database has the table, and to create a database, you need to follow a procedure called schema. So schema create a database, or you can say vice versa as well. Okay, database. And database, what is it? It's a collection of related tables, and this is defined by schema, and then in turn is also called database. It's interesting, dude, when you learn this way. Okay, anyways. Uh, is it? We need to say. So we learn the tables, the rows, number of rows or number of column is fixed, and the order of the column is fixed. Plus, each column will have a name. Rows, it can be random, does not have identifier, so it can have identical rows. Dude, this is getting interesting. And each column has a data type. This is interesting. So apart from a column name, they have data type. But what is data type? The data type constrains a set of possible value that can be assigned to a column and assigns semantic to the data stored in that column so that it can only be used for computation. Assign semantics. Semantics, I think it should be rules to that data. What is semantics to a data? Semantic to a data type defines the meaning, purpose, and interpretation of data, moving beyond its structural format string int to explain what the data represent in the real world. For example, email address, a user ID, or a currency amount. It add contextual metadata, allowing system to validate, render, and process data more intelligently. Context versus structure. While a data type syntax define how data is stored, semantic define what it means. For example, a string data type might semantically represent. Oh, okay. Syntax is how it is gonna store the value in the database, but semantic define what exactly it represent. But okay, okay. So this one is more towards my computer side. This is more towards the world side. The thing is, the column. This is the column, right? Column 1, column 2, column 3, column 4. And we told you that column have two fixed things. First one is number in a table or the SQL table. Second one is your column order. This is fixed, not gonna change. But one thing you need to understand, if this table represents the world data, that means this column represent two things. First one is syntax. That means what kind of machine data it will store. Like, is it integer? It is gonna be your string or boolean or anything. This is machine level. Semantic is all about what it represent in real world. So as a developer, what we are trying to do, we are trying to replicate real world into mm, machine world, right? Like binary 0 or 1. So how it is stored here, it become data type or syntax. What it represent becomes semantic. That's a really interesting way of putting the words together. Okay, that's it. Close it. For instance, a column declared to be numerical type will not accept arbitrary text string, and the data stored in such column can be used for mathematical computation by contrasting a column declaring to be a characteristic string type which accept any kind of data, but it does not lend itself to a mathematical calculation, although other operations such as string concatenation is available. So syntax as a data type will give you what kind of an operation we can perform on it, so it restrict its uses. That's a good thing. PostgreSQL include a sizable set of built-in data type that fit many application. User can also define their own data type. That's what I was talking about. Postgres being highly customizable. So you can create your own data type. Most built-in data type have obvious name and semantic. So we defer a detailed explanation to chapter 8. Some of the frequently used data type are integer for whole number, numeric for probably possibly fraction number, text for character string, date for days, time for time of the day value, and time is time for value considering both date and time. To create table, you use the aptly named create table command. In the command, you specify at least a name for the new table and the name of the column and the data type of each column. So when you create the table or when we are gonna create a table, we need to again you remember for database we create database and then database name. Drop database the database name, right? We did that. Now for creating a table, we use create table name, and in the brackets we define the columns because we know rows or entities we're gonna define, but for a structure we need is what kind of attributes the entity gonna hold. And attributes are nothing but column which have fixed number of attributes and the order should be fixed. So here the order is first name and the second name. And what are the data type like? It's mean what kind of information I can store it. That will define what kind of a operation I can perform on this data type. First one is text and second one is integer. So first column and second column. Okay. Create a table. My first table with two column. The first column is first column as a data type text, and the second column has the name, second column, and the type is integer. The table and column names follow the identifier syntax explained in 4.41. Type name are usually also identifier, but there are some exceptions. Note that the column list This column separated, surrounded by parentheses. Okay. And if I have to drop it, I can simply use it drop table, table name. Same as how I created database, create database name, drop database, database name, create table, table name, and the attributes of the column definitions, that is column name and the data type separated by column, common, comma, and then drop table, table name. Okay, let's quickly create our before my this will happen anything else. So in a student, we have a schema. So schema, let's we are suppose we are working on the request for student personal student personal. Okay. Now I go to the student here. I ask him what is requirement for personal one. So he said, in the personal, you don't have to do much. I need to store. This is the conceptual. We are just talking, gathering. I need to store my name, my age, then the university I'm studying, and my address and university address. I want to store this one. That's it. So I found it like all this are relevantly related with one another. I don't need to create multiple tables. So what I will do, I will create a single table with student details, right? I will have one column that I will put the name. So it's a name and it will be string. Then I will create age, that will be integer or number. Then I will create university, again it will be a string. Then I will create address, it will be a string. Then I will create university address, that will be string. So this is the logical view how it gonna look like, because based on his requirement we have only, we don't need only this much in this schema. Okay, now implementation. This was conceptual, this is logical. Now we will create physical implementation. So for table creation, so database creation, right, we are working on the database. So in this database, we need to create a table called student details. So we will be like create, create table, and table name is student underscore detail. In the table, apart from this text, we need to have parenthesis ended by semicolon, and the columns. How many columns we need to get? One, two, three, four, five, five. So first one is name, and it will be text. Since this is the all column name, column data type, and comma, to separate to the second column. Okay, but else it will think it as a single one, and it will be hard for him to understand what is the column name, what is your data type. Second one is age. Obviously, it's gonna be integer. Then your university name is gonna be text. Then address, text, and university address is going to be text. And this is how we will be able to create our first table. Let's quickly create it. So create table. And now see, right now I'm in a database called student, and I have created the schema. So I'm working, schema is nothing but the roadmap to a database, right? But for this database, I am working with two requests. First one is student personal, one is student professional. So there is a two space within this database. So to access a particular one like a student personal, I need to go to the student personal student. So I am working on this schema student personal, right? So I need to access student underscore personal, right? PR or personal. Okay. Now dot will give me like, I need to go to this schema because I'm already in this database. In this database, I am working on this particular schema for this particular request for this database, right? And I need to create the table in this schema that is called student detail. That was the name, right? We decided on. Yes, student detail. and I will start and end with semicolon. Now the first column was name, that was text, right? If you see here what it does, here is a data type. Text will have strings or alphabet of English letters, right? Second one was age, that was integer. Third one was university. Okay, again text. I can put university underscore name for more contextual, but university will work for time being. Second one was address. That's again text. And third and last one was university address. And that's text. University. And let's write it down anyways. Name. Address should be student address. But since I'm talking about the student, but again, let's be more specific. So it becomes student address, university name, and less. Now I told you always that the number of column and the order of the column is fixed, right? So let's quickly run this first, and even I will like to showcase one I'm writing, but I will teach you this one. So this one is asking me to retrieve all the information, select star means retrieve all the information. Since I'm already in this database student, retrieve all the information about a table called student detail from a schema called student personal. So schema is nothing but a roadmap or a blueprint of a database or roadmap to create a roadmap to a database, or it's just how a database is created. Roadmap to a database or process to create a database is called schema. Right now, for this particular database, I have a two requests. One is personal and professional, and I found it that I should create two different requests for this one. So first one professional, I pick the logical, then I create a conceptual, logical, and ultimately physical. So I have this table into this schema. So let's run everything. So syntax error. Why I can't create it, dude? A student underscore personal. What's happening? Why? Why it was created? Table. See, student details created, but why it did not run for this one? Student personal, student detail. I don't understand this one, dude. They should run for both. Let's see. Okay, it's running. Let's do one thing. Let's drop the table and then recreate it. Drop table for table student detail in a schema called student personal. Oh, now I got it. I got it. I got it. What happened? Okay, so my mistake. When I said this one F5 execute a script. A script means the entire sheet of this paper. So it's gonna execute line 1, line 2, line 3, line 4, line 5 till line 11. This one will execute the query on which my cursor is present. If my cursor is here, uh, do you think I can create one more here? I was thinking to create one more of. I think that's possible here, where I can create multiple tabs. Leave it time being. But we understood that one, that if we have to run a particular query, then execute this one. it will execute that query. And if I have to run all the script, all the codes in this paper, then I have to press this one. So you see the column is created: name, age, university name, student address, and university address. But I found it very, very disturbing that the student first to detail and then the student detail as address is in between university name and university address. And we know at a given point of time, a SQL table have fixed number of column and fixed number and the fixed order of the column. And it doesn't look good. So I will just take this off here, go here and paste it here. So you see the column is for column segregation. The last one will won't have any column because there is no column after this one. And now I will execute the, see now if I execute the query, it will fail error because it's already existing, right? So I cannot, so see my cursor is here and this one. So what happened? It will go up and down and we'll see the query, and he found this is the query. And it was tried to execute the query, but he found that table is already existed, so he cannot create another table. But if I drop it and then create it, then select, then it make a completely different. That means I need to run a script rather than an individual query. I press it here, successfully run. Now name, age, student address, university name, and university address is coming. Now again, by default, I know the name belong to student because there's a student detail, so I don't have to put it. And that was the reason I thought you should not put this to here because it's a student detail, right? And that's how you need to bifurcate or take this out. It's called normalization, where you put the relevant data to a relevant tables. That we will learn later, but right now this is not important. So I go back to this person, and so our detail was right. On the concept level, we know we need to store the name, age, his address, then university name and university address. Then I realized that in a conceptual level, why don't I create two tables? One is student detail and second one is the university detail. Here it will be student name, age, and university ID. And the corresponding ID will be available here: university ID, university name, and university address. Why? Because suppose this particular student your personal schema, suppose there are 10,000 students from different colleges, right? And out of them 2,000 is from the same college, and suddenly till 2025 they have name as KVS, but after 2005 they decided to rebrand it to KEVS. Now you will need to update all the column. That is cumbersome. And you see in this record 10,000 records, 2K records are constantly occupying the space that is recurring, redundant, the same information coming again and again and again. So they will occupy more space. What you can do, you can replace this with some number one, two, some ID, and store this information into another table that will now hold only two rows: the university name and university address, and the university ID 3, and the ID is also available in this one to make a reference, right? So you are saving space. This is called normalization to break down. That means now we can create two tables. One will have the unique ID, then university name and university address. And this ID, people can use it in their personal student detail table. So it will reduce the redundancy. So we start doing that. Okay. So firstly, what I will do, I will already drop this one. I will create a student. I will take this off, and rather than that, I will take this off. Let me recreate this one. Okay. Now this one I understood on the logical level that I can create one in universe student detail and one is student detail. University detail, university detail. Okay. In the student name, I will have name, age, and university ID. That will suffice a lot of things. Now I can rename it to address because now this is only to my student. Okay. When you have this conflict of like two different name as a suffice, that means there's a problem. You need to bifurcate or you need to break this down. Now I can put it just university ID and ID I can put as integer. Correct? This I will do it. Here I will create university detail which will have couple of more things. I will remove the name. I will have university ID as integer, right? Now what I have to do at any given point of time in this relationship, if a student is if uh, if there is a record or entity for a student, he should belong to a university. That's by default. He can't be a student if he's not enrolled anywhere. That means this unique ID cannot be null. Second, it cannot be null. Second, it should have a value that exists here by default. So there's a restraint here. Restraint. The student can come into existence when there is a university ID and the university ID exists here. So it's called referencing. There is ID here and the corresponding ID should be available in this column for a student. This can be achieved using primary key and foreign key concept. So what we will do, so every university is unique, right? So it will be like, uh, I don't remember how it was does, but I think prime, primary key and as primary key, foreign key. So leave it. Once we go into the constraint, we will read it. I'm not putting it, but you understood, right? Why we did this teacher. Teacher. Now I will have, I'm not doing it right now because I don't remember how to do it. And that's the exact reasoning for this live session that we will learn together. Now let's run the script. Okay. There's a problem with university name. Oh, see, I told you. This is the one you will find. There's no comma. So now you're confused. Which one is the column name, which is your integer? That's why you need to define it properly with this syntax. That's why it's structured. You need to follow a particular. That's why it's called language because it have a proper syntax and the keywords. Now, see, university is coming. Why I see only one output? Because once this output was displayed, it was overwritten by this one. So if I just time being place it below, see, mm, university already. Okay, so now I haven't dropped this table, right? So I'm trying to create it again when it's already existing. So I will just drop this. So first it will drop this to table that created again, and then I will select it. See, another mistake that is column. You need to make sure that was I was talking about. If you don't put it and you have two different commands together, it will get confused that this is something that doesn't resemble to my syntax, so it's failure. That's why you need to make sure all the commands is ended with the semicolon. Now you see it. Earlier it was student name that was overridden by university. Now university structure is overridden by this one. From for this relationship that I told you, primary key and secondary key or the foreign key that we will learn eventually. But why I want to tell you guys to understand two primary concepts. One is normalization, denormalization, like breaking and joining together, and how in the logical view you create different tables and then link them based on the IDs and why we do it to reduce the redundancy and increase the efficiency. We will learn in the project way, the grander way as we move forward. But for today, I think And that's enough. If you have any doubt, nobody join. This is still fine. But I learned a lot today. This is really interesting, dude. I don't know why, but I learned about the schemas. The schema is a process of creating a database based on certain requests, where the first layer is conceptual, where I will gather the information, then I will create the logical view, and then I will create its implementation in database. Either I can directly use a public schema where every table belongs to the same database, or I can create a sub database using schema to make it much more fragmented and much more secure. I really love this one. Before I close the stream, let me check. Apart from this one, there's anything. I think tomorrow, what we need to focus on, create and drop is done. Alter is left. We will look into this. Not a big deal. Tomorrow, we need to delve more into alter and data types. I think default value identical and data types. Machine queries. This is the one we need to go into. This is the schema I was talking about, creating a schema, public schema, the schema search path. A database contains one or more named schemas, which in turn contain tables. A schema also contain, but what is it? PostgreSQL database cluster contain one or more named databases. Role and few other object type are shared across the entire cluster. A client connection to a server can only access data in a single database, the one specified in the connection request. This is the one we are talking about. In a connection, I can only connect to one database at a time. Note, user of a cluster do not necessarily have a privilege to access every database in the cluster. Sharing of role name means that there cannot be different role name, say Joe, in two database in the same cluster, but the system can configure to allow Joe access to only some of the database. Okay. A database contain one or more named schemas, which in turn contain tables. This is the one I was talking about. So initially what we were defining database is a collection of tables. That was true for all the one, but here in PostgreSQL, they created one intermediate level where you can also group the table based on your requirement. That's how I grouped it, personal and professional one, right? So to group them in a database is called schema. So database is not a nothing but a collection of schemas, which in turn is a collection of related tables. So how so the main agenda behind the database is to create a segregation in such a way that related data can be stored together, making it easy to access, more secure, give the access to the right person, and processing become much more easier. Right? That's the concept of database. So database is nothing but a collection of related tables. But in Postgres, they created one more layer where within the database they are creating a group of related columns or tables, and they call it schema. So schema is nothing but so this schema and that schema is completely different. You don't have to merge this together. In Postgre, the schemas means is a collection of related tables, and it also database is a collection of schema, which in turn is a collection of related tables. But in general, the more specific schema, if I have to look now, a schema is nothing but a blueprint of a database. How we are converting a conceptual idea into logical and then implementing that into tabular form. It's nothing but a schema, right? We are creating a schema because databases are just a collection of similar schema, collection of schemas. The schema also contain any other kind of object, uh, other kind of named object, including data type, functions, operator that we need to operate in this entire database. Within one schema, two objects of the same name cannot exist. Furthermore, the table. So I think tomorrow we need to learn about the schema as well. Uh, I think tomorrow we're gonna cover this part, table definition. Okay, and then we will also cover data types. But in data types, okay, tomorrow we will target to number five, and then data type. But in data type, we are not going to learn. I think if it's not much, we will do it very quick and fast. Or we might take one day more. That's fine, no worries. But tomorrow we're gonna start from here till here, and we will learn about this one and see if we can start with the data types. Tomorrow we so today we learn about the data creation. Tomorrow we're gonna learn about data definitions. In fact, I think that's it for today because I need to work on other